Hi students, my name is Samuel Emeka. In this video we shall use technology to determine sample linear correlation coefficient and the least squares regression line. This presentation shall be on my website www.samuelchukwuemeka.com. Our objectives: we shall use technology to determine the sample linear correlation coefficient, otherwise known as the Pearson product moment correlation coefficient, and also the least squares regression line, otherwise known as the line of best fit or the linear regression equation. Please, before you continue with this video, it is highly recommended that you view the videos on slope-intercept form, sample linear correlation coefficient, and the least squares regression line. In these videos, I solved the calculations by hand. So it is advisable that you learn how to do it by hand before you learn how to do it with technology. What technology shall we use? We shall use Windows-based technology, which is the Pearson Statcrunch and the Microsoft Excel. You can watch out for other videos whereby we will use the SPSS and other technologies as well. So let's look at example 1. Consider the data. You're given the data. Remember that X is the independent variable or the explanatory variable, and Y is the dependent variable or the response variable. So you're given 4 values of X and 4 values of Y. Draw a scatter plot of your data. Compute the linear correlation coefficient to 3 decimal places. Assume you add an additional point, which is a 10.4 and a 9.3. You know, this is a point has 2 coordinates, the X coordinate, which comes first, and that is 10.4, and then the Y coordinate, which comes second, and that is 9.3. So that coordinate means that X is 10.4 and then Y is 9.3. So assume you add this, draw the new scatter plot with the additional point, compute the new linear correlation coefficient to 3 decimal places. What are your observations? So let's start with this first. We have our data already. You might want to write it down, 2.3 and the rest of them. Okay, so I have let's start with Statcrunch. Now the Statcrunch is on my MATLAB, in your window on my MATLAB. I already put mine up. So when we come over to Statcrunch, yours might not be like this. Yours might have your data, some data sets already here. It does not matter. Okay, whichever one, it does not matter. You can. I just started with an empty data set. So our variable 1 will be our X. Our X will be a variable 1, var1, and our Y will be a variable 2, var2. So when we come over here, we type in a 2.3, 3.9, 2.8, and 4.7. That is our 2.3, 3.9, 2.8, and 4.7. Then here on the Y, 3.9, 1.4, 3.7, 4.9. So our Y, we have a 3.9, 1.4, 3.7, 4.9. So the first question says you should draw a scatter plot, then you should find the linear correlation coefficient to 3 decimal places. Okay, so you want to do the correlation, you will click on Start. When you click on start, you go to regression, and this is a simple linear. You select simple linear, and another window pops up. It asks you what is your x variable. Select the column. Our x is the var1. That's the independent variable. We usually want to start with our x. Okay, now in some textbooks they might start with y, but it's just a good practice to start with x, the independent variable. If you view my videos that I did by hand calculations, I kind of explain this in details. This is just using technology to show this. So I don't intend to make this video very long. So our y variable is our var2. And once we get it, we click next. And we are not concerned with the hypothesis test right now, or finding any statistic using a specific confidence interval. So we kind of skip this step. We click next. And we are not predicting y right now for x equal to something. So we leave it for now. We are not finding residuals or fitted values. So we leave this unchecked as it is. We leave it like that. We click next. Now we want to find our scatter plot. So we want to check this, plot the fitted line. And that is the only thing you want to check. You are not interested in finding any confidence interval or adding prediction interval. Likewise, you leave all these unchecked. Then you click next. And if you kind of want to make your graph to be colored, you might select red to blue or grayscale or many shades. Otherwise, you might just want to leave it in default as it is. Then you click calculate. So once you calculate, let me expand this so that we can see it well. You will see the result here. You will see that the regression equation is y equal to 3.2674983 plus 0.060584463x. And this is your regression equation right here. And this is your correlation coefficient, 0.0443. There is no correlation. I mean, it's zero correlation because of the low correlation coefficient. So that is typically what you want to do. So we've kind of answered the correlation coefficient. To 3 decimal places will be 0.044. To 3 decimal places, 0.044. So let's click next to see our scatter plot. And this is kind of your scatter plot. You see how this is scattered. These points are scattered. So there's a very weak correlation. Well, I would say no correlation because it's 0.044. Yeah, it's very low. So is practically no correlation between the points. So this is your scatter plot as it is now, and this is your correlation coefficient. Now this is your regression equation, or the least squares equation, least squares regression equation. Yeah, remember that your var2 is your y and your var1 is your x. Okay, now if you look here, intercept and slope. Remember I said that you need to view the slope-intercept form as a prerequisite. You see that the slope, remember that your least squares regression equation is b1x plus b0. If I kind of take you back, to let me open up a new slide. If I kind of take you back to linear functions, your mama ex-boyfriend, y equal to mx plus b, you will see that m is the slope, and b is the y-intercept. So this is in linear functions, something you did in algebra. right? It's something you kind of did in algebra, but in this case, in linear equations, we see this as a, let me kind of change the font. If it was linear equations, we now see this. This is for linear equations, linear functions. Okay, your mama ex-boyfriend. Now, if it was linear regression, we now see this as y hat. Okay, I just write it as y hat so that I don't go and start looking for the symbol, and that will make this video to be long. Is a b1 x plus b0. So if you kind of look at this, okay, 1 is a subscript, so let me make it a subscript. 1 is a subscript and 0 is a subscript. So if you kind of look at this, okay, you see that the b1 here is the slope. In this case, our b1 is the slope, and then our b0 is the y-intercept. Now, so that is kind of a relationship when you kind of look at it, that was where it came from. Now with this y hat, I hope you know, if you want to find it, you insert, it's probably a symbol. Yeah, but it will waste our time, but you know what I'm talking about. Okay, that this is the equation of the least square lines, or the least squares regression equation, or least squares regression line. That's the formula here. b1 is the slope and b0 is the y-intercept. So it's kind of comparable to these linear functions. Okay, this for linear functions, this for linear regression. Okay, and that is what it is here. Now, some textbooks, b0 comes first. I mean, it all depends. But this, if you look at the way this one was written, b0 came first, b0, and this is the y-intercept 3.2674983, and the slope is 0.060584463. That becomes the slope. The slope is the one that is close, that is the coefficient of x. Okay, the coefficient of x gives you the slope, and the one that is a constant is the y-intercept. All right, the next question we are asked to find is, assume you add an additional point, 10.4 and 9.3. So this means that I will go here, I add additional points. This means 10.4, and this is 9.3. So it says we should still draw the new scatter plot that has it, and we have to compute the new correlation coefficient, and then we talk about our observations. So you still go to start, you go to regression, simple linear, your var1 is your x, and your var2, variable 2 is your y. Click next, click calculate, so that we don't, okay, we didn't plot it, I'm sorry, we have to start all over again. Start, simple linear, var1, var2, next, we are not predicting, we plot the fitted lines, next, and let's kind of use this one, red to blue. Let's kind of color this one so we can see how it is. So this is your new one with the extra point you added. So you see that the correlation coefficient is now 0.8651. That is very positive. That's a almost strong correlation. Okay, 0.8651. That's very positive. Very strong relationship. Well, not very strong, but it's a strong correlation, strong relationship. And see our intercept, see our slope here. And if you look at it, you substitute it, it gives you the least squares regression line equation right here. So let's go and look at our graphs, and you see now our observation. This is now with the colored points. If you look at it now, just check it out. This one, we have this one. Check this one out. Just check it out. So look at these points. Let me minimize it. And if you kind of compare them, you will see these are scattered points. This point right here, the last point, the last coordinate, which is 10.4 and 9.3, it makes this to be more, to show more strong relationship. So, and that brings us to one of the uses of scatter plots. Correlation coefficient correlation coefficient alone is not enough to tell the relationship. Sometimes we need that's why we always need, not sometimes, but always we need the scatter point to tell us. If you look at the last point right here, it is very far. If you study all the points, they are close together, but you look at this last point, it is 10 point something, right? But all these points are kind of close together. This is 2 point something, 3 point something, 2 point something, 2 point something, 3 point something, and 4 point something, kind of close together. But this point is very far, 10 point something. And because of this point, it has now made the correlation to be strong, to have a more positive, strong correlation coefficient, which shows a strong relationship. So what does this tell us now? As if you look at the video I did with the calculations by hand, we see that the correlation coefficient is not resistant. Any outlier can affect it right away. Now this 10 point something is an outlier. It's very far. Is a high point. It doesn't follow the usual trend of the other 4 points. So it has affected it right away. Okay, so correlation coefficient is not resistant. It will immediately react to any outlier. Any outlier can affect the value of the correlation coefficient. Let's now go to using Excel to do this. Okay, let's do this with Excel. I have my Excel open, and already I have my data analysis tool pack. I talked about this data analysis tool pack in the videos I did earlier on using technology to determine descriptive statistics. So if you don't have the data analysis, when you click on data and you don't have the data analysis, please view that video, watch that video, so you know how to put in the data analysis. Okay, this is Excel 2010. Yeah. So what we want to do now is we want to solve this example 1 with Excel. We've solved it with Statcrunch. We want to solve it now with Excel. So we put in our data here, 2.3. We go ahead and put in our data, 3.9. Let me finish with 2.3, 3.9, 2.8, 4.7. And we do so here, 3.9, 1.4, 3.7, 4.9. Okay, so there are two ways we can do this. The first thing we would do is to use this function here. We can kind of use this function here right away. Let's say we want to place our correlation coefficient here. Let's say correlation coefficient, and you know it's R, correlation coefficient. And I kind of I kind of want to extend this, okay, and maybe make this bigger so that we can see it. And maybe here will be a slope. Let's use that as a slope, and let's use this as a y-intercept. Okay, so we go to this function right here, insert function. We click on insert function, and if you do that, it comes to most recently used. Okay, you want to select statistical. When you select statistical, you now look for correlation coefficient. If you look for correlation coefficient or correlation, we see correl. You see correlation coefficient between two data sets. Another one we can use is what we call Pearson. So you can use correl or Pearson. Product moment correlation coefficient R. So let's use a correl here. Correl. You click OK. It asks you for your first array. The first array should be usually your X. You get your X first array. Then your second array, you get your Y. And as you do that, you see right away that this is a 0.44275151. You see that? Yeah. Now, remember, this one is the one we use for correl. Let me put it correl. Remember, the function is correl. Okay. Now, we can also have the correlation coefficient, but Pearson is still the same thing. It will still give us the same thing. Let's see. Pearson. So we click f of x. We look for Pearson. P. You just press P so that, well, here you can press P. Pearson says returns the Pearson product moment correlation coefficient R. So you click OK. The array 1 is a set of independent values. Independent is our X. We select it. Then array 2 is a set of dependent values. Dependent is your Y. You select it. And it gives it to you right away. You click OK. You see it's the same thing. Okay, so any of them can give you the correlation coefficient, whether you use correl or you use correlation, that's what it means, or you use Pearson. Now the next one is your slope. To find your slope, you can kind of look here for slope. If you put S, slope. Or another thing you can do actually, if you don't want to do this, is you can come here. It says type a brief description of what you want to do, and then click go. So let's type what we want to do. We want slope, and then click go. So it brings it right away, slope. So you click OK. So it asks you for your Y. Now be careful, our Y is not the first one. This is our Y here. You select your Y. Then the X asks you for X. You select your X, and it tells you the slope right away. Okay. And then your y-intercept, the same thing. We can, in this case, in the slope we used slope, and for the y-intercept we use intercept. I think I'm kind of deviating because I'm now going into finding the least squares regression line. I'm sorry, because I was supposed to just find correlation coefficient and then draw the scatter plot. But anyway, let's just find the intercept and then we can move ahead. The intercept, we click on this and we can look at, remember, statistical, then we look for intercept. I just press I, intercept, comes to you. The known y's are this is the known y, and this one is the known x. Drag it. Okay, so these are intercepts here, 3.26 that. So you see that your y, your least squares regression line will now be y equal to, of course, b1x. b1 is the slope here, b1x plus intercept. Okay, so excuse me. So let's continue. That will be your least squares regression line. Now let's go ahead and find this plot, do a scatter plot of this. To do a scatter plot of this, we want to go to data, insert, insert, not data. You go to insert and you see scatter here. You click scatter plot, and when you click scatter, you want to see all chart types. Then you click XY scatter, you select OK. When you select OK, you need to, before we do this, we have to select our data. We have to select our data. Then we go to insert, scatter, all chart types, XY scatter. X comes first, Y comes second. Okay. And when you do that, you see this is a scatter diagram if we are using Excel. Now don't count this as one of the points, it's not among. Okay. If you check it with the one we got from I've deleted that one. The one we got from Statcrunch is the same thing. And then you can right click. When you right click, you add trend line. And it's a linear trend line. You click close. So this is kind of the trend line. Okay. So this is what we have here. Then let's when we now add the next one was 10.4 and then 4.9. I'm sorry, 9.3. 10.4 and 9.3. Let's do our scatter. So yeah, you see it now. Scatter, all chart types, XY scatter. Okay. So you see this one. Let's compare the two ones. If you add this, so you right click here, right click on one of the points, add trend line, and we have a linear, should be linear trend line. So you see the difference now. This point has made the correlation to be more strong positive correlation. Yeah, strong correlation. And if we want to get our new correlation coefficient, we can either use the Statcrunch, or we can either use f of x function. This function we can either use Pearson or Corel. So, but assuming we use Pearson, array 1 will be independent values, which is x, and array 2 will be dependent values, which is y. So this is the new one. You see, that was what we got from our Statcrunch, 0.8650. Yeah, it says to 3 decimal places, so it will now be 0.865. Now this is one way. One way is to use this function, fx, insert function. Another way you can do this is what we call data analysis. If you go to data analysis, you if you go to data, you click on data analysis, and here you find correlation. Correlation is there. You click OK. Input range. Now in this case, your input range is just XY. So you want to start from here and drag this all the way here as your input range and click OK. If you click OK, well, we took this to be a new worksheet. You know, let me show you what I did. It comes to a new worksheet, like go to data analysis, correlation, get this. It says new worksheet. So this is sheet 1, sheet 2, sheet 3. It will bring it on a new worksheet, which is not bad. Okay, we can check it. So we have what we got. Let's expand this. So we have a 0.865 if we round it up to 3 decimal places. Just exactly what we have here, 0.865. And if we remove this, you know, if we remove this, we will get 0.044. If we remove it. Okay, so that is everything about the linear correlation with Statcrunch and then with Excel. All right, now let's do example 2. Example 2, it says the data below shows the number of days absent and the final grade for the students in a teacher's class. So 0 absences, final grade is 87.1. 1 absent, 1 absentee, final grade is 77.5. Okay, it says now find the least squares regression line, round to 2 decimal places. So, and then interpret the slope, interpret the y-intercept, predict the final grade for a student who misses 1 class period, round to 2 decimal places, compute the residual, what are your observations, draw the least squares regression line on a scatter diagram. Okay, let's start with Statcrunch. With Statcrunch, let's leave this like this, it doesn't matter. Let's start with a variable 4. Okay, and type in our stuff 0, 1, 2, 3, 4, 5. Okay, and this is 87.1, 77.5. Now if you want to type the first and second column, that's fine, variable 1 and variable 2, that's fine, but I will waste some time if I mean, if you want to erase it, that's fine, but I don't need to erase it. I'll just leave it like that. So 87.1, 77.5, 78, 68.4, and 68.9. Let's make sure we got every data right. 78, 68.4, 68.9. Okay, so it says find the least squares regression line, interpret the slope, interpret the y-intercept, predict this. Okay, so we go to start, as usual, regression, simple linear. In this case, our x column is 4 and our y variable, y column is 5. Okay, we click next. Please don't make mistake on that. Don't make mistake on selecting this. If you know you make mistake on this, it is better that you erase this and type it new. You click next. You click next. Now this is important. It says predict y for x equal to what? Okay, so they say predict the final grade for a student who misses 1 class period. So for x equal to 1, let's find what y will be. So we check this box, and when we check it, this becomes active. The text box becomes active. If we uncheck it, the text box is not active. We check it. We now put for x equal to 1. And we want to find a residual. They ask us about residual, compute the residual. So you check the box, save residuals. Okay, now I hope you know residual is observed y value minus the predicted y value. That is the formula for residuals. Okay, then you click next and you check plot the fitted line. We want a scatter plot of that. Draw the least squares regression line on a scatter plot. Okay, and we click next, and do we want color? We don't, we just leave it like that. We click calculate. So you find out this, that the least squares regression line will be y equal to 85.08 minus 4.55x. You see that right here. This would be the least squares regression line here. Okay, and when you want to predict for x equal to 1, student who misses one class period. So that means x is equal to 1, which means x is the variable 4. So you just do 85.08 minus 4.55 times 1, right? Because variable 4 in this case will be 1. So 85.08 minus 4.55, it gives you 80.53 right here. So even if you don't calculate it, you can get the predicted y value right here. See that? Yeah. So this is your least squares regression line. This is your predicted y. This is your correlation coefficient, although they didn't ask you to find it. It is a weak, very weak or no correlation. The next thing they ask you to find is what? Interpret the slope and interpret the y-intercept. Okay, in this case, you see our slope is negative, right? So that means the slope is delta y over delta x, change in y over change in x. In this case, the change in y, the grade, change in the final grade per absent, change in the final grade over change in the number of days absent. So, and this number of days absent, you see, it is like an increment of 1. So the slope kind of tells you that the change in the final grade, average change in the final grade per an additional absence is negative 4.55. Yeah, that's the slope right here, negative 4.55. And then intercept is the 85.08. If you want to interpret it, it's kind of, now you know that if you recall on the video I did on slope intercept form, to find y-intercept, you make x to be 0 and solve for y. To solve x-intercept, you make y to be 0 and solve for x. So the intercept is the final grade because it's the y value. This is y-intercept. It is the y value, is the final grade when there is no absence. And that is 87.1 if you're looking at it from here, but we don't look at it from here. We look at it from the least squares regression line. So this is the final grade for a student with no absences. Okay, the final grade for a student with no absences is your intercept, because at that x will be equal to 0. Okay, the next one is predict the final grade for a student who misses one class. The final grade will be 80.53. And then compute the residual. So let's compute the residual for this. It tells us here that the residuals are stored in new column, residuals. So we have to move here and see. So our residual here is for our residual here is for a student who misses one, is the residuals is negative 3.03. And it makes sense, because if you look at the observed y value, If you do 77.5, right, minus the predicted y, if you do 77.5 minus 80.53, it gives you what? It gives you negative 0.03. That's the residual. Remember, it's observed y minus the predicted y. Yeah, it gives you that right here. Okay, the next one is the observations. Of course, we observe that if you look at this, you observe that the predicted y is greater than the observed y, the actual y, the predicted y, which is 77.5. I mean, the predicted y, which is 80.53, is greater than the observed y, which is 77.5. So this tells you that the final grade is greater than the predicted y for the final grade. The predicted final grade is greater than the observed final grade for that number of absences, which is for 1 absences. And it further tells you that if you look at it here, it is below the regression line. It is below the regression line. So that's that's what you can interpret it as. These are the 5 points you have. So it's below the regression line. Draw the least squares regression line on a starter diagram. That's the regression line here. Okay, so let's do this with Excel, right? Let's find the least squares regression line with Excel. Remember, I'm not going to delete this. Remember, this is what we got here. 85.08 minus 4.55x. So if we do that with Excel, what we want to do here, let's look at sheet 2, a new sheet. We can find the slope and intercept. That is what we can do, or we can still use data analysis. We can use data analysis and do that. But in any case, we need to type in our data. So let's type it real fast. 0, 1, 2, 3, 4. And then for y, we have 87.1, 77.5, 78, 68.4, and 68.9. So we want to click on data analysis and we scroll down to regression. When we go to regression, we click OK. Input y, this is our y, we select it. Input x, this is our x, we select it. And we want it on a new worksheet ply, that's right. We want the line fit plots, right? Okay, so we just click OK. And let's kind of look at this table to interpret it. Let me kind of expand it a bit so you can see it well. Now, we will be using this later on as we go in, as we do more work on this course. This is kind of a lot. Okay, so excuse me. We see that the intercept we have here is 85.08, and the slope x variable 1, that's what they call it here, negative 4.55. And if you look at the Statcrunch, that is what you have. The only thing with the Statcrunch is that they write it out for you. Yeah, but this is 85.08 minus 4.55. See, y equal to that. So this is the least squares regression line actually here. Okay, now let's look at the if you look at the data, the line fit plot, it tells you the y as against the predicted y. So it kind of shows it to you how the two does, y against the predicted y. Okay, what other thing do I need to teach you now? The next thing is you can now find out other stuff on your own. Remember, you can also do slope. The slope, if you don't want to get it from here, this is the coefficients, which means this is the slope, and this is the y-intercept. You can also get it from from here, and it will give you the same thing. Let's do that and call it a day. So let me type slope. Go slope. Oh no, I didn't place it well where I should be. Let me place it here. What will slope will be? I can kind of expand this a little bit. So I do here, I go to slope. Y is this, X is this, and I click. Oh no, I'm doing, you know what, something is wrong. I'm doing something else. I'm doing the other one. The sheet 6 is what I should, sheet 2 is what I should be doing. The sheet 2 is what I should be doing. Remember, this is our slope, and this is our y-intercept. Remember that. So when I do this here, this sheet 2, go to f of x, slope. Well, I don't want it to be there, so I put it here. Let me just put it here. F of x, slope. The y is this, and the x, come on, Sam, dumb. Y is this, okay, and then the x is this. So did you see that? 4.55 is the slope. See that? And if we call this a y-intercept, y will be this, and x will be this. So 85.08. See that? What we got here? 85.08, 4.55. Okay. So you can do all this either with Statcrunch or Excel. Play more with this. Play more with this stuff. I just wanted to tell you, to show you how you can do this, so it saves time. Now your Excel, your Statcrunch, you can always, you have the option of saving it. If you want to save it and email to me, you can export to my result, right? You can export to my results. You can copy it. If you click on export to my result, it kind of does the folder for you, but that's not what I want to do. So you can copy it, or however you want to do it. All right, students, thank you so much for listening. I think we've solved the 2 questions. If you have any other question, please feel free to contact me. Thank you so much for listening, students, and you have a great day.